Hey Math 1, we're back with part 2 of 3.4. So we've switched from and statements to or statements, which if you recall or statements, they literally mean the union, which I translate as to graph every element of both solution sets in the most concise way. So in the most economic way, the one that sort of like simply tells what's going on. Graph every element or every point of each solution set. So I think it's awesome to get the visual first, so let's do that. 2 and 5, 1, 2, 3, 4, 5, 6. -1, -2. So in black, I'm going to put an open circle at 2 and make everything less than. In red, I'm going to do an open circle at 5. Again, everything less than. Now, this is the trickiest part. Or statements tend to be the one that confuse students. And what they share, there's a visual, right? You see, okay, they're both there, less than 2. But for or, you're graphing every single element of both solution sets combined. So, in the final graph, I want all the solutions for x is less than 2, in addition to all the solutions for x is less than 5. So, here's the thing. X is less than 5 contains all the solutions in x is less than 2. Everything for x is less than 2 is already in x is less than 5. So what we do is we say x is less than 5 is the solution set. That's my final answer when these two are put together with or. And then your final graph is going to be just x is less than 5. Open circle at 5, going this way. I know, it's kind of tricky. I know this. All right, do the same thing with number 6. So or means graph every element or every point of the solution set. So graph every point of both solution sets. Which, if you check it out visually, you got 3, 6, 9. Open circle black on 3. Open circle red on 6. So you can summarize this entire graph if you're saying graph every point of each solution set by saying, hey, if everybody in the 6 is already in the x is less than or greater than 3, I can just reduce this solution set down to x is greater than 3. And then just graph x is greater than 3. Open circle, everything to the right. Some students visually, if they graph it identically to what I did, is they say the big graph is always or. The big graph is always or. The small graph is always and. Small graph would be and. So I don't know if that helps you guys. I'll explain it better in person. All right, let's check out number 7. So x is less than -1 or x is greater than 4. We're graphing every point of each solution set. So I don't know if I need to write this every single time, but you get the idea, right? Now, I think I will write it every single time. I really want you to get the idea. Graph every single point in both solution sets. Every single point contained in both x is less than -1 and x is greater than 4. So when I graph both of these on a number line, 1, 2, 3, 4, 1, 2, that's enough. In black ink, I'm going to go x is less than -1. In red ink, I'm going to go x is greater than 4. I've graphed every element of both solution sets. I graphed every element here. I graphed every element here. There's no conclusion to make. This is a normal case for OR statements. Which means I don't have to change anything here. That is my final answer. And here, I don't have to change anything on that graph either. That is my final answer. All right, so that's the normal case for OR. Let's talk 8. All right, so you got x is greater than 2 or x is less than 4. I think this one's probably the most confusing of them all, but we'll see if you guys understand it. So I'm graphing every point. I know this is getting kind of tiresome, but I really want to hammer it home. Graph every element of both solution sets. So 2, 4, 6, -2. So in black ink, I'm going x is greater than 2. In red ink, I'm going x is less than 4. So what would better describe every element of all the x's greater than 2's and all the x's less than 4's? Well, this goes on forever. So everything, so 2, 2.1, 2.7, a billion, everything all the way through infinite values that way are all solutions for x is greater than 2. For the x is less than 4, we're talking, again, all of these points, but then you've got 0, -1, -2, -2.3, -5, all the way to negative infinite values. Those are also a part of the solution set. So it basically is like everything from negative infinity to positive infinity are included in this solution set. So if you're getting super confused right now, I'll just lay it all out there. All real numbers are the solutions to this inequality. All real numbers represent this solution set. So how do we graph all real numbers? We basically embolden the entire number line. Every point on the number line is a solution. All right. Again, I think this is a good place to stop. These are all the special cases we've talked about so far, the basic special cases in which OR is involved. Thanks for watching. I'm going to make one more video of the weird special cases. So hopefully we have the endurance to tackle that as well today.